Hi, welcome to this channel. In this video, I am going to discuss about exercise 1.2 of number system. ಈ ವಿಡಿಯೋಲಿ ನಾನು ನಂಬರ್ ಸಿಸ್ಟಮ್ ಯೂನಿಟ್ ನ exercise 1.2 ಪಾರ್ಟ್ ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So let's see the question. State whether the following statement are true or false. Justify your answer. That first question is every irrational number is a real number. First ನಾವು ಕಲ್ತಿರೋದು natural number ಬಗ್ಗೆ, then we learned about whole number, then we learned about integers, then we learned about rational number and irrational number. Last we learned about real number. In the previous video also I told that you have to follow this order. Here all the natural number also are a whole number, all the whole numbers are integer, and all these numbers are real number. Real numbers mean that include all these natural number also, whole number also, integer also, and rational and irrational number also. So real number is the set containing all this number. So irrational number is also a real number. Real number containing rational number as well as irrational number. Real number contains rational number and irrational number. So all the irrational numbers are real numbers, but all the real numbers are not irrational number. Reverse order is not applicable. All the rational numbers are real number, but all the real numbers are not rational number. So next, see the second question. Every point on the number line is of the form root m, where m is a natural number. Every point on the number line is in the form of root m, where m is a natural number. So to solve this, first we have to draw one number line, right? Then we have to mark each number, and distance between the each number should be 1 centimeter. 0, 1, 2, 3, minus 1, minus 2, minus 3. So first ನಾವು ನಂಬರ್ ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡಬೇಕು. ನಂಬರ್ ಲೈನ್ ನಲ್ಲಿ ಈಚ್ ನಂಬರ್ ಮಧ್ಯೆ ಡಿಫರೆನ್ಸ್ 1 ಸೆಂಟಿಮೀಟರ್ ಇರಬೇಕು. ಸೊ ಇಲ್ಲಿ ನೀವು ಈ ಎಲ್ಲ ನಂಬರ್ಸ್ ಅನ್ನು ನೋಡ್ತಾ ಇರಬಹುದು. ಎಲ್ಲ ನಂಬರ್ಗಳು ರೂಟ್ ಎಮ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆಯಾ? ವೆದರ್ ಆಲ್ ನಂಬರ್ ಇಸ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ರೂಟ್ ಎಮ್. If you take 2 we can write in the form of root m, right? We can write square root of 4 also. Why? Square root of 4 is nothing but 2. In the same way, you can write 1 also, square root of 1. It's also in the form of root m. Whether m is a natural number? Yes, this 1 is a natural number, 4 is also a natural number. But what about this 2 and 3? Can we write in the form of square root? If you write in the form of square root also, m, what we are getting, that is not a natural number, right? Only for the first perfect square number, when you take the square root, we are getting natural number like square root of 1, then square root of 4, square root of 9, square root of 16. When you take the perfect square numbers square root, you are getting the real numbers, sorry, natural numbers, right? When you taking the square root of the perfect square number, you are getting the natural number here. But when you take the square root of 2, square root of 3, you are not getting the natural number. So this question is false. Every point on the number line is not in the form of natural number. And when you come to the left side, here we have negative numbers. Negative numbers, when you again take the square root, you are getting negative number only. And square root of minus 1, you can write as 1i. I is nothing but square root of minus that we can writing as minus 1, that is writing as I, or square root of minus 2 that you can write as 2i, where I is square root of minus 1. So here also inside this square root we are not getting the natural number, that is negative integer. So this question is false. Every point on the number line that is not in the form of root m, and it is also not a natural number. M is not a natural number. Are the square root of all positive integer irrational? If not, give an example of square root of a number that is a rational number. So here we have to write the square root of the positive integer. We have to check whether that is irrational or rational. Let's take the square root of positive integer from start. 1, 2, square root of 2, square root of 3, square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9, and square root of 10. Enough. So what is the square root of 1? 1. Square root of 2, that will come around 1 point something decimal. 3 also the 1.5 something decimal will come. Square root of 4, that is 2. And then we know square root of 9 here, that is 3. Right. So which is square root of 2, that is irrational. Square root of 3, that is irrational. Square root of 5 is irrational. Square root of 6 is irrational. 7 is irrational. Square root of 8 is irrational. Here square root of 1, square root of 3, and square root of 10. These are irrational. When you solve that, we are getting a non-terminating term. That is not have an end. ಯಾವಾಗ ಈ ನಂಬರ್ ಅನ್ನ ನಾವು ಸ್ಕ್ವೇರ್ ರೂಟ್ ತೆಗೆದಾಗ ನಮಗೆ ಎಂಡ್ ಆಗದಂತಹ ಟರ್ಮ್ ಸಿಗುತ್ತೆ. ನಾನ್ ಟರ್ಮಿನೇಟಿಂಗ್ ಅಂದ್ರೆ ಎಂಡ್ ಆಗಲ್ಲ, ಆ ನಂಬರ್ ಕಂಟಿನ್ಯೂಸ್ ಆಗುತ್ತಾ ಹೋಗುತ್ತೆ ಅಂತಹ ನಂಬರ್ ಸಿಗುತ್ತೆ. ನಾನ್ ಟರ್ಮಿನೇಟಿಂಗ್ ಟರ್ಮ್ when you are taking the square root of this number. But what about this number, square root of 1, square root of 4, square root of 9? These are the square root of the perfect square numbers, right? 1, 4, 9 ಇದೆಲ್ಲ perfect square number. ಸೊ ಯಾವಾಗ ನೀವು ಪರ್ಫೆಕ್ಟ್ ಸ್ಕ್ವೇರ್ ನಂಬರ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅನ್ನು ತೆಗಿತೀರೋ ಆಗ ನಮಗೆ ರ್ಯಾಷನಲ್ ನಂಬರ್ ಸಿಗುತ್ತೆ. ಈ ನಂಬರ್ಗಳು ಇರ್ಯಾಷನಲ್ ಅಲ್ಲ, ಈ ನಂಬರ್ಗಳು rational. Rational means that we can write in the form of p by q. So how to write 1 in the form of p by q? That is nothing but 1 by 1. Then how can we write 2 in the form of p by q? You can write 2 by 1. 2 by 1 also 2, right? Or you can write 4 by 2. 4 by 2 is also 2. Or you can write 8 by 4. 8 by 4 is also 2, right? So 2 also we can write in the form of p by q, that is a rational number. And 3 you can write as 3 by 1 or 6 by 2 or 9 by 3. The same way you can write in different form. So 3 is also rational number. We can write in the form of p by q. So square root of all the positive integer are not irrational. Some of they are rational also. Square root of 1, square root of 4, square root of 9, they are rational. So this question is false. All are not irrational. Some of they are rational also, like root 1, root 4, root 9. When you are writing the answer, first write false, then write some of the numbers are rational also, like root 1, root 4, root 9. In this way you can write the answer. Now let's see the next question. Show how root 5 can be represented on the number line. So this is difficult to do in the laptop. Better you can do in your book, but in roughly I will do in here. First you have to take your scale and put one straight line using your scale. Then measure each 1 centimeter. Okay, 0, 1, 2, 3, 4, sorry, not 4, -1, -2, -3 left side. After this first step you can do is you have to take 1 centimeters you have to keep your protractor here. You have to measure 90 degree. You have to take straight, you have to draw one perpendicular, that means 90 degree. You can keep your protractor like this and measure 90 degree. This point you should keep here at 1, and here you have to measure 90 degree. Then you have to draw 1 centimeter straight line. Then you have to join this point to 0. So this value is root 2. Root 1 value is 1, that comes here only. This is root 2. Then again you have to repeat the same procedure again. You have to keep your protractor like this. This point you have to keep here. In the protractor middle point will be there, right? That you have to keep here. Then you have to measure 90 degree. That will come somewhere here. Then draw 1 centimeter straight line. Join that to 0. This is root 3. Then again you have to keep your protractor here. Measure 90 degree 1 centimeter line. Then join that to 0. Then you are getting root 4. The same way repeat that same procedure. Keep your protractor like this middle point here. Then measure 90 degree 1 centimeter straight line. Join that to 0. You have to do by your scale. Here in the PC I can't do by scale, so I am doing by hand. So join that to 0. When you for root 5 you are getting 4 triangle like this. Then after that you have to take your compass. You have to take this measurement from here 0 to this measurement. Then you have to draw one arc. When you are drawing the arc, that will come somewhere here. Square root of 5. This is square root of 5. That will this is square root of 1, square root of 2, square root of 3, square root of 4, and this is square root of 5. That will come somewhere here. Then here you have to mention this is the square root of 5. This is a number line. We mention square root of 5 on the number line. You have to draw this using protractor and compass. Don't do directly by hand. Here I can't do by protractor and compass. That's why I done using hand. So last step is you have to keep your compass here. This measurement, take this measurement in compass from here to here. Then you have to draw arc right side. So this is the value of root 5 on the number line. This is the first procedure. One more procedure is take the number line like this. 0, 1, 2, minus 1, minus 2. Also here first you can take 2 centimeter line here. At 2 centimeter you have to draw 1 centimeter straight line. Join that to 0. Then here which answer diagonal you are getting, you have to take that measurement and draw diagonal here. So this is the value of root 5. Why this is the method also true? Why this method also true? Here nothing but, see here we can apply Pythagoras theorem. You can take A, B, C, right? So square of the hypotenuse equal to sum of the square of the other two sides. So AB square is equal to AC square plus BC square. What is AB here? That we don't know, we have to find, right? What is AC square? AC is 2 here, so 2 square plus BC. BC is 1 centimeter. So 2 square is 4 and 1 square is 1. The answer is 5. So AB square is 5. When you are taking the square root of 5, we are getting AB. So AB is here root 5. So this step also you can follow. You can take 2 centimeter here, then 1 centimeter straight line, join that to 0. Then by your compass take measurement from this to this and draw arc here, right side. So this method also true and this method also true. You can follow any method that is your wish. Okay.
Thank you for today's video. If you like the video, please share it with your friends. Thank you.